In my another vector tutorial. In this time we are trying to solve question number 7 from exercise 13.3. all the questions are taken from Cambridge Admit book. Let us start question number 7. From here it's the information provided. Well, we are going to start any vector equation or any solving. You need to first read the information what provided in the question, and the information written on the left side, and there is a diagram also given on the right side to solve these two questions. The first one, OA vector is given. OA means from here, let me see what the vector is. OA vector, this is the vector A, it is written here, and OB is B, this is the vector B is given, and O is the origin, it is written here. OX equals to lambda OA, OX is in that direction, in the direction of OA, and OI in the direction of OB in terms of mu provided here. The first question is asking us to find out BX. Let you write BX, so we can use, and it is written here in terms of lambda, we have to go, we can write here BX as a OX minus OB if we write according to the position vector. So OX is provided here lambda OA, let you write lambda OA, and OB is vector B. So our final expression for this question is lambda A minus B, and A and B is the vector in that particular direction. This is the first part of this question. A1 we have done, BX. Then the second part of this question, it is written here AY. Let you write the AY here, AY. This is the second part of this question. AY, it is written here in terms of mu, we have to find out the answer. It means that we need to use the OY part. So let you write in terms of position vector, we can write it easily OY minus OA. Then OY provided here lambda mu OB, and we know OA equals to A. Let me write this mu B, OB is B provided, minus A. So this is our answer of this second part, and B and A actually considered as a vector here, that's why I make it bold. Then jump to the next part of this question. The portion provided 5 BP equals to 2BX and AY equals to 4PY. From O to B first, then from B we can write there BP. These are vectors. So B vector is given here, OB vector is given here B, and BP is provided 2BX by 5. So we can write 2 by 5 of BX equals to B plus 2 by 5 of BX. We already, BP equals to 2 by 5 of BX, so we change it. So BX, we already have the value BX. Let me use this, which is, this is lambda A minus B. So inside of that you can write lambda A minus B because BX is provided. Now let me write the whole thing, which you can write 2 lambda A by 5. First we are going to write A part, then if we take B common from there, we can write here 1 minus 2 by 5B. if we take common, actually B minus 2B by 5, 2 by 5, yeah, if we take B common, then the final part 2 lambda A by 5 plus that part is 5 minus, so it gives us 3 by 5B, 3 by 5B. Here A and B is the part of the lambda. This is total of the OP. Now another OP we have to find out with the second part, but in terms of mu we needed to do. This is the first one. Second one I'm going to write here. The second one is another OP letter. It is written here AY. This is the best option to do that question, PY. Let me break down this information because we already have AY, you can use from there. So left side AY, this is the information AY provided. Let me write mu B minus A and from the right side you can write it, say OY minus OP, because our target is to make OP as a subject from here. So let me write mu B minus A equals to 4OY minus 4OP. So make 4OP as a subject, 4OP as a subject, then it gives us 4OY. 4OY, we can replace 4OY as a mu OB. 4OY means mu OB. And another part of the vector, we can write it, say left side we can take it on the right, A minus as a minus mu B, because I took it on the right side. 4OP equals to, we have to use a plus sign here. So now let me write 4OP equals to 4 mu B plus A minus mu B. So first write A, then B, we can 4 mu B minus mu B, which is 3 mu B, and make OP as a subject. From there we can write here 1 by 4A plus 3 mu B by 4. So this is the part, another OP in terms of mu, and that is the question answer of OP. Now the last part, we are already part 3. It is the question asking you to find out the mu and lambda, but we already have the 2 OP, so we can form our one vector equation from there. Let me form vector equation. I'm going to use the different color in this stage, where in question number 3 I'm writing here OP equals to OP, one OP in terms of lambda, another OP we are going to write in terms of mu. So OP in terms of lambda, this is the information in terms of lambda. Let me write 2 lambda A by 5 plus another part is 3 B by 5, and here A and B is the vector. So on the right side I can write it 1 by 4 A, then plus 3 mu B by 4. On the right side let me write this. That is the vector on the left side and right side. Now we are going to equate the coefficient of vector A, because it's a vector equation. So if we equate the coefficient of A, I'm writing here the vector A from the both side, equating the coefficient of vector A from the both side, then we would get from there 2 lambda by 5 from the left side. I got this, and on the right side coefficient of A is 1 by 4. Let me write 1 by 4. So from here you can easily find out the value of lambda, which is 1 by 4 into 5 over 2, and it gives us 5 over 8. This is our answer of lambda constant. Another one is mu. By equating another part, coefficient of B from the both side, let's say coefficient of B from the vector equation. This is our vector equation I wrote here. We are equating the coefficient of B from here, which we can write 3 by 5, and on the right side coefficient of B is 3 mu by 4. So we can cut out this 3 and 3, so mu we can write as a 4 by 5, and this is our another constant mu. Hope guys the way I did the question you understood properly. Next time, in next tutorial, I will show the question number 8, and as well some other questions from the next exercise, and that the questions are from exercise especially 13.4. questions are relevant with the board exam question, and from board exam question definitely we'll get some question to solve. So stay tuned in my channel to get more videos like this. Thanks for watching with patience.